We started to implement the NumberTriviaBloc in the previous part, and you learned the basics of doing test-driven development with streams. In this part, let's finish the block implementation so that we can move on to dependency injection next. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your coding skills. We already implemented an important part of the logic which runs whenever the GetTriviaForConcreteNumber event arrives in the block. That's the input conversion. However, after we have the successfully converted and validated integer for which the user wants to get some amazing number trivia, we aren't doing anything with it, we are just throwing an unimplemented error. So let's change that. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and go through this lesson at your own pace. What should happen after we have the successfully converted and validated integer is that we should call the use case getConcreteNumberTrivia in order to actually get the concrete number trivia. So definitely our naming conventions live up to expectations, because really you can literally see what this use case should do when you call it. So again, as usual, we are first going to create a test for this functionality. So we are still inside the GetTriviaForConcreteNumber group because we are testing by events. And whenever this GetTriviaForConcreteNumber event arrives inside the block, after we have tested everything else regarding the input converter, the next test will be again arrange act assert test, where the block should get data from the concrete use case. Here in the arrange part, we are again going to return what we've been returning from the input converter, the successful parsed number. So let's just copy that for now. And with this number successfully parsed, because if it's not parsed successfully, the block should immediately emit an error state. So in that case, the execution of the block's logic ends there. But if the conversion is successful, we continue on with the following code. And also, of course, we are going to have to mock the actual use case. So when the mock getConcreteNumberTrivia use case is called with any number, then we want to answer, because that's actually asynchronous, and we want to answer with the right side of either, because we want to simulate success, and it's going to contain the number trivia, which we've created in the last part. It's just simply an instance of our number trivia entity right here inside this group. And after we have arranged the test, we're going to act. So we're going to call block.dispatch. We can just copy it from the previous test. And we're going to dispatch getTriviaForConcreteNumber with the number string. And then, similar to how we needed to await until called with the input converter, because otherwise the assert part would run even before the logic had a chance to be executed inside the block. So we need to await until called. And this time we're going to wait for the mock getConcreteNumberTrivia to be called with any argument. And now inside assert, we just want to verify that in fact the mock concreteNumberTrivia use case was called now with a precise argument. And we are using the params object to pass in arguments to our use cases. So we cannot just specify that it should be called with the t number. No, we need to wrap it inside params. And the params for getConcreteNumberTrivia can contain a number. And that number will be the t number parsed, which is returned from the input converter. So whatever is converted inside the input converter and subsequently returned from it, the same number should be passed into the use case. That's what we are testing here. This is the simplest test of them all, because we are not expecting anything, we're just verifying if something has been in fact called. So of course, this is now going to fail, And that's because we are currently only throwing an exception from within the NumberTriviaBloc whenever the conversion is successful. So let's now implement this functionality. It's pretty simple. We are just going to create a regular method with curly braces, or actually higher order function with curly braces to be more precise, from which we are going to call getConcreteNumberTrivia and pass in the integer which we have over here. But of course, I have even forgotten that we need to wrap this inside params. So params number is the integer. All right. And now when we run the test once again, it should pass. And surely it does. And before moving on to other tests, let's refactor our test code a bit, because over here you can see that we are mocking the input converter to return the successful response, the number parsed, and we are doing the same over here at the top. So let's extract this into its own method, which will be located inside the group. It will be of course void, and it will be called setup mock input converter success. And it will simply return, or actually not return, just call this when. And now we can replace all of the occurrences of this long-winded when with our custom method call. So let's replace it in the first test here and also in the last test, which we've just created. So we should rerun the tests just to make sure that our refactoring did not break anything. It shouldn't have, but just to be safe. Now, of course, just simply verifying if the concrete number trivia use case was called is not enough. We actually need to display the trivia gotten from this concrete use case in the UI using states, which are emitted from the block. But even before displaying the actual trivia, we should probably let the user know that something is going on, because of course, getting concrete number trivia from the remote API will take some time. And we want to show some progress indicator, something spinning on the screen to let the user know that the app is not just frozen. So which states should the block emit when calling getConcreteNumberTrivia use case is successful? Well, it should emit empty first, because that's always emitted. That's the initial state. But then it should emit loading state and then loaded state. And the loaded state will actually contain the number trivia the user is interested in. So let's create another arrange act assert test, which will say should emit, and now the states, which we write simply in square brackets. The states will be loading and loaded when data is gotten successfully. So data should be gotten successfully. So again, we're going to mock input converter success, and also we're going to mock that the use case also returns successful the number trivia and not some kind of a failure. So let's just copy and paste it over here. Actually, now we're going to be testing with streams. So we are again going to, instead of arrange act assert, we are going to arrange assert later and only then act. So let's change this to assert later. And here, what we want to assert is that the expected emitted states, so final expected, is equal to a list of states which should be emitted from the block. And again, the first state always has to be the initial state. So we are going to say empty. And also you could specify block.initialState, maybe, if you like that better, but I just like empty better than specifying initial state always. It's shorter. And then the next state should be loading, and finally loaded. And what should this loaded state hold? Well, of course, the number trivia, which we've set up in the test group. All right. And now, of course, we need to expect later. And we expect that the block's state stream will emit our values. So emits in order, and the order of the values emitted or the states emitted will be the expected list. And now, after we have registered our expectation, we can call block.dispatch with the t-number string as we are already used to. So we are calling it or dispatching GetTriviaForConcreteNumber event. Now let's run this, and it's of course going to fail. How else? So let's go right into NumberTriviaBloc and implement this. We should first return the loading state. So we need to yield loading. And again, similar to how we have to have the failure function be an asynchronous generator, we need to do the same for the success function. So now we can yield something from within this higher order function. And then this getConcreteNumberTrivia returns either. So similar to how we store the either inside a variable for the input either, we want to do the same for our final failure or trivia. And once we have failure or trivia object, which is of type either, of course, we want to yield a state. And currently we are testing for when the data is gotten successfully, in which case we want to emit loaded. But again, here comes the power of either, in that we have to handle both failure and success. So we cannot just somehow circumvent this. As I've said in the previous part, we have to handle both cases. So we want to yield whatever will be returned from the failure or trivia. Why cannot we specify that? IntelliSense does not want to cooperate this time again. Or actually it does want to cooperate, but I've just forgotten to specify a wait, because of course this is asynchronous, so pardon me. Now we can call failure or trivia dot fold again. And if there is a failure, because we are currently testing for success, we're just going to ignore failure again by throwing an exception, which will be unimplemented exception. So let's do just that, or unimplemented error as it's properly called. So we're going to throw this. And if the call was successful, so if right, we're going to receive the trivia object over here, in which case we want to simply return loaded and pass in the trivia as trivia argument. And so we return loaded state from the fold method, which in turn is yielded from our async generator and so on up the chain. Eventually it's gonna get into the stream of number trivia states. So now running the test should pass. And now we can move on to what should happen if the call to getConcreteNumberTrivia returns some failure. In this case, those failures can be cache failure or server failure. So we're going to create another test. In fact, it's going to be so similar to the last one we've created for the success that we're just going to copy and paste it below. And this time it should of course return loading still, because even when we get some error from the use case, it still happens asynchronously. So we have to show some kind of a loading indicator to the user. And then we are gonna want the error state to be present. And this is gonna happen when getting data fails. All right. So now we are still going to mock input converter success, because we are going to get to the point of calling the use case only when the input converter actually is successful, because if it's not, we are immediately going to yield error. So only if it is successful can we get to calling the use case here. But what we want to change is that the getConcreteNumberTrivia mock will not answer with right t-number-trivia, but instead left. And let's do server failure. So we need to import that over to this file. And now we should assert that the states emitted are not empty loading and loaded, but instead the last state will be error. And here it's pretty important to specify a correct message. So because we are emitting or getting server failure from the use case, the message should be server failure message, which we have created in the last part. This is simply the string constant. And all of the other code of this test can remain as it is. So let's now run this, and it's going to fail, of course. So let's go to NumberTriviaBloc, and instead of throwing an implemented error from the failure side of either, we're going to return error and pass in the server failure message as the message. So let's run this again, and this time it passes. But of course, the problem here is that we cannot just simply put the server failure message always into the error. What's going to happen when the GetConcreteNumber use case returns a cache failure? Then there should be the cache failure message, right? But something like this is currently not in the tests. So let's create a test that will make sure that only the proper message for the failure is inputted into the error state. And it's very important to handle all of the possible types of failure inside the block, because it's important to show the user a precise and meaningful message. It's not enough to just handle the base class failure and call it a day. We need to handle every single subtype. So let's do that right now. We're going to just copy and paste the test below. And we're going to call this that should emit loading error, yes, with a proper message for the error when getting data fails. All right, that's quite a long name for this test. But anyway, instead of server failure, we are going to return cache failure from the ConcreteNumber use case, and then the message which should be there in the error state will be cache failure message. So now let's run this test again, and it's going to fail. So now inside NumberTriviaBloc, we're going to spawn a monster here, but don't worry, we're going to fix it in just a little while. That's because, just to make this as simple as possible, we are doing TDD after all, so we are just writing the least amount of code possible for the test to pass. We're going to put a ternary operator in here. So if failure is server failure, we are going to return the server failure message. Of course, we need to import server failure or failures.dart file to be more precise. And otherwise, we are going to put the cache failure message into the error state. So this code is definitely not good code. It's not even readable very much. But anyway, this should make the test pass. And only then later on we can go on to the refactor phase, because remember, with test-driven development we are doing red, test fails, green, test passes, and only after the test passes are we going to really refactor. Some exceptions may apply, but mostly that's what you should be doing with TDD. In addition to this being unreadable, this ternary operator is actually quite unsafe, because what if the failure type is not a server failure, nor is it a cache failure? Of course, we do not have any kind of other failure which can happen inside here. Still, if we had some unexpected failure here, the message would still be the cache failure message, which is not cool. That's because this last part of the ternary operator is basically an else clause. So now to make this safer and also more readable, let's extract this ternary operator into its own method, which will be private inside the block. We're going to call it map failure to message, and it's of course going to return string. It's going to accept the failure. And sometimes I wish that the darts extension methods were already here, because we could do it really nicely with an extension method which would be local to this class, but still they're just working on it, so we have to create these kind of stupid helper functions as of now. But anyway, we are going to switch here And we could of course do if failure is and specify server failure and so on, but we can also do it with a switch statement. I think it's nicer. The way we can do it with switch is that we're going to switch over the failure's runtime type. And now we're going to provide cases for this switch. So in case that the failure is server failure, we're going to return server failure message. In other case, when it's cache failure, we're going to return cache failure message. And finally, sadly, Dart still doesn't support any sealed classes or tagged unions or sum types or however you want to call it. So we have to handle the case when the failure will be none of these, and we're going to handle it with the default clause. And in this case, we are going to return a string called unexpected error. Because it's really unexpected that this is going to be even returned, because there is no even possibility of having a different type of failure passed into this map failure to message method after all. And even though the Dart team, as of speaking now, is already working on adding sealed classes or something similar to Dart, if you want to learn how to work with sealed unions, which is a package fixing up missing Dart's functionality, check out the video from the card in the corner. And now, of course, we're just going to call map failure to message instead of this ugly ternary operator and pass in the failure. And that's basically all there is to do for us. So now, because we have refactored the code, we need to rerun the tests, of course, and they should still pass because we have not changed anything extreme. And now with this, we have successfully implemented the whole logic which should run whenever the GetTriviaForConcreteNumber is dispatched to the block. But there is also another event, and that is GetTriviaForRandomNumber. And as we are already used to, the random event, when that is triggered, will be very similar to what happens when the concrete event is triggered. But with one exception, it's going to be much simpler, because with GetTriviaForRandomNumber, we do not have to handle input conversion because there is no input. It's just a random number generated over in the remote API. So because of that, let's go over to the test file and we can actually copy the whole group for GetTriviaForConcreteNumber. So copy it, paste it below. We're going to again break the methods of test-driven development for the sake of us not getting crazy, because these implementations are really similar. But in addition to just renaming things to make them work with the random event and calling the random use case and so on, we can actually delete a lot of code in here, because the input conversion and validation will not happen. So we can remove the test should emit error when the input is invalid, and also the first test, which tests that it should call the input converter. So we can delete the first two tests. And of course, we no longer need to have input converter success here, because input converter will not be called from within GetTriviaForRandomNumber. So let's rename that. And also, because we are not validating any input, we are not going to need tNumber string nor tNumber parsed, because they are not needed. We just need the tNumber trivia, because everything else is basically just generated inside the remote API. We do not care about the inputted number. So now let's fix up all of these tests one by one, and then we are going to implement the whole functionality of the random event inside the block after we've modified these tests. So the first test should get data from the random use case. We're now going to mock input converter. So the use case will be mock get random number trivia. And the random number trivia use case does not take in any parameters. So what we've done is that when something does not take any parameters and it's a use case, we can specify no params, right? And of course, we would also need to import no params over here. But because we are just mocking it, we can still just pass in any and check for no params only in the verification part. The event which should be dispatched is of course GetTriviaForRandomNumber, which does not accept any arguments. We're going to wait until getRandomNumberTrivia use case was called, and then getRandomNumberTrivia use case, on it we want to verify that it was called with no params. Now we're gonna do the same thing for the method below, so for the test below. So should emit loading loaded when the data is gotten successfully. That's correct. That's what should happen also from the random event, because the only thing that changes is that we do not convert the input. So let's copy the mocked random number trivia use case from above. The expected states can remain the same, and so expect later can remain the same as well. And the dispatched event should again be GetTriviaForRandomNumber, and that's about it for the changes to this method. Next, again, we're simply going to just mock the random number trivia use case again and dispatch the random event. So let's copy and paste it. And of course, you can get all of this code from the written tutorial, and over there you can also get the whole project. So definitely check it out from the link in the video description. Lastly, even for the last test, we're going to do the same thing. So mock the random use case without the input converter and dispatch the proper random event. And once we've done that, we can now run the test code, and it's going to fail, of course. And we're going to get to NumberTriviaBloc, and we're going to do the simplest thing possible, and that is to create an else if, and we're going to check if the event is GetTriviaForRandomNumber. And here we are simply going to copy and paste the code from above after integer was successfully validated and converted. So let's just copy it from within this integer higher order function and paste it into this event handler, so to say. So we're going to yield loading, and then instead of getConcreteNumberTrivia, we are going to call getRandomNumberTrivia. And basically the only other change which will happen in here is that we're going to call it with no params. So let's also import usecases.dart. And with that, we can now run the tests again, and they should pass this time. Well, that's interesting that they do not all pass. So let's take a look at what happened. It should return empty, loading, and error, because we are in the test for testing the errors, but instead it returned empty, loading, and loaded. Oh, that's right. We are returning right side, not the left side, even from the error tests. So here you can see why test-driven development done the right way is awesome, but doing test-driven development with just copying and pasting code is actually pretty bad. It's still better than if we did not have any tests, but still, we've made a mistake in the test just because we were not following TDD precisely. We are going to return not right side of either, but left side, of course, which will hold the server failure in this case. And in the test below, it's going to return left with cache failure. And with that, we can now run the tests again, and they should pass this time. All right, so now it's time to remove the code duplication, because there is not a lot of it actually inside the block, but still we can do better. If you take a look at this code, what we are doing in both of the functions or in both of the clauses of the if statement is that we are yielding failure or trivia.fault, and then we yield either or return an error or a loaded state. So let's extract this functionality into its own method. We are going to highlight it and say extract method. Let's call it, it will be private, so underscore either loaded or error state. And it's going to generate us a method, but of course its return type is wrong for some reason, so we have to change it manually. Let's also add a comma so that it will be formatted for us. And we need to change the void return type to be stream of NumberTrivia states. And after we make this method to be an asynchronous generator, so async asterisk, we can now yield from it failure or trivia and return error or loaded. And now we can call this method from both of the clauses of the if statement, but we should also yield each. So yield asterisk. And we are of course going to do the same for the random event. And with that, we can now run the tests again because we've refactored the code and they should still pass. And they do. So now we have the block fully implemented. It has its dependencies in place. We are calling them from within the map event to state, and we have it fully tested, and the code is looking pretty decent. And also, because we are using the either type from the darts package, we are forced to handle errors or failures, even though we might not want to handle them. We just cannot go around that. Unless we are really clever, but of course, you can always go around something if you really want to, but it's much easier to go with the flow where you have to handle a failure, and at least you are definitely not going to forget about it as you would if you were just using regular exceptions all over the place. To go through this tutorial at your own pace once again, and also to get all of the code, check out the written tutorial available from the link in the description. We are getting close to the finish line because now that we have literally every bit of logic implemented, it's time to put all of the parts together with dependency injection in the next part, and then, well, there will be nothing more for us to do than to create the user interface. So if you do not want to miss those parts and also more tutorials like this, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you with implementing the block finally, give this video a like and also share it with other developers who will surely benefit from it too. Leave a comment if you have anything to say, any suggestions or questions, and see you in the next video.